My name is Steve Krpata. I'm the PureAir North American Industrial Sales Manager, and I'll be your host today for this webinar. We're going to discuss the topic of coconut carbon media versus PP blend. And we'll be hitting these primary points on this slide of history of coconut carbon media and some of the features of it. Also pulp and paper mill chemicals, and then the use of engineered adsorbents for treating it and comparing that and contrasting that to coconut carbon media. And if you would please hold any questions until the end of the presentation, where hopefully we will answer everything. There are four aspects of air that need to be treated in order to effectively treat corrosion in the air and to preserve the electrical components in the space. You have chemicals, particulates, temperature, and humidity. In this webinar, we're going to primarily deal with the issue of removing corrosive chemicals using gas phase filtration, because chemical particles are too small to effectively be used with particulate filtration. We will specifically compare and contrast the use of coconut carbon media with the use of PureAir's PP blend media. Coconut carbon has historically been considered an excellent go-to media for removing the gases that cause odors in the air. Some people even ingest it to settle their stomach and pull contaminants out of their body. Coconut shell carbon media has traditionally been considered the premier carbon media. And carbon media has a huge number of small micropores, so it's great for VOC control, volatile organic compounds control, which are a normal gaseous state at room temperature. Unfortunately, there are more corrosive chemicals to combat in cleaning the air than VOCs. A standard method for broadening the reach of medias are to impregnate them with select chemicals to create a nullifying effect for the target chemicals. In the case of carbon media in pulp and paper mills, they have traditionally been impregnated with potassium hydroxide to help broaden their effectiveness. Unfortunately, carbons need large micropores for impregnation, so trying to impregnate the carbon with is not a particularly effective method because it tends to clog the smaller micropores, reducing further the airflow, and the smaller micropores do not accept the chemical impregnate very well as compared to a macropore. Then you additionally have a byproduct of chemical reactions in the level of heat, and heat can be generated to a point where the carbon media spontaneously combusts, which makes pure carbon media a fire hazard. Here you have, we have some photos of some media beds that have actually caught fire, and so you can see what the effect is of some of the damages. And in a paper mill, pulp mill, fire is one of those things that you just don't want, especially if it's near a particularly hazardous process like a PSM process, where that could be disastrous. As it is, recently there have been several mills that have had their scrubbers catch fire, and they have had to evacuate the mills and shut down the paper machines, which would cost millions of dollars in lost profits from foregone production. Um, so here you have, let's see, we are showing here some more pictures of media bed fires and some of the damages, what they look like. And now in the current climate of supply chain issues and hyperinflationary pressures, coconut carbon media is particularly problematic since coconuts are grown in Southeast Asia and India. They are not readily available in the United States, and they can be especially difficult to obtain on short notice. Even cost of carbon from coal, which is easily substituted for coconut carbon media, and while being more readily available, is rising rapidly due to the increasing hostile environmental constraints that are being imposed on that sector. Coconut carbon media in its natural state is flake, which is somewhat of a problem. We can ameliorate that by extruding the carbon media into cylinders, which enhances the airflow. During dusting is another problem with carbon media, which normally can be handled by using after filters for the media bed. But on occasion, I've seen these fail, and they'll still allow dusting into the space, which is being treated. And particulates, as you recall, from the anyway, so particulates, you recall, are one of the 4 corrosion hazards we are trying to prevent from entering the space. So actually adding particulates is not a good one. Through absorption, molecules enter a porous substance, such as carbon media, and by adhering through its ions to a surface area. And in certain circumstances, this process can be reversed in the process of can be reversed. In the process of chemisorption, on the other hand, there's a chemical process where the molecules react and actually form a different substance, and they will, in the case of the PP blend for PureAir, it turns into a non-hazardous salt. Pulp and paper mills, specifically, and electrical room corrosion protection industry generally, has a broad array of chemicals that need to be neutralized to control corrosion and odors. Carbon media, even when impregnated, does not handle all the chemicals presenting themselves. So to completely clean the atmosphere and the electrical spaces and create pure air and overcome the shortcomings of solely using carbon media requires a different approach. To satisfy this need, PureAir Filtration has developed PP blend, which is a combination of 50-50% of sulfazorb 2 and PureAir 8. Sulfazorb 2 is 50% extruded cylinder shaped carbon, 50% aluminospheres, which are each impregnated with a caustic compound and a proprietary reagent to neutralize acidic acids, and it's UL listed, so it's not a fire hazard. PureAir 8 is a spherical porous pellets, which are formed from a combination of powdered activated alumina and binding it suitably with 8% potassium permanganate to provide optimum absorption, adsorption, and oxidation of a variety of gaseous contaminants, which cause corrosion, odor, and unwanted gases, oxidation, which and it's also UL class 1 listed, so it's not a fire hazard. The purple color of the potassium permanganate is used as a visual indicator. As it turns brown, the potassium is being used up. If you crush the aluminum balls and they're brown all the way through, then the pellet is completely used up. So the 50-50% blend of PureAir 8 and Sulfazorb 2 and PP blend, as the name implies, creates a blended media that's less expensive than carbon media components alone. And there are, to go over the advantages again, there are, it's less expensive than carbon media, and the pricing, even under the current inflationary supply chain environment, is not as volatile as it is with the coconut carbon media. PP blend is UL listed, so it's not a fire hazard. PP blend does not have the same dusting issues that straight carbon media has. Here's a list of pros and cons comparing the two different medias. One of the things I would note on here, which might be a little deceptive, is for example, the hydrogen sulfide in the first line is showing that it reduces it 26% by weight. The weight of PP blend is more than that of carbon media. It's more like 48 pounds a cubic foot, whereas coconut carbon media is about 35 pounds. There's a broader range of gases that are treated with PP blend than with straight carbon media, even if it's impregnated with potassium hydroxide. PP blend is more robust than a straight carbon media, so it lasts longer under the same chemical loads. The purple potassium permanganate provides a visual indicator of the remaining life of the media. And the Chemisorb process converts the treated chemicals in the air into non-hazardous salts, so there's no hazardous chemical issues to deal with. This slide compares the attributes of the various high-quality engineered absorbents in the various medias that we've been discussing here, and highlights the ones we've been discussing. We'll provide these slides to you so you can review them leisurely at your own pace. PureAir, at PureAir, we pride ourselves on using our comprehensive PureAir solution to removing harmful and annoying gases at your facility by identifying the problem or problems, designing the appropriate solution based upon a range of products and services in conjunction with customer requirements. And then we follow through with the implementation of the solution, and finally continuously monitor the environment to maintain the systems and the media. Another distinguishing PureAir approach from our competitors is that they advocate changing the media based on the calendar, with deep bed systems generally being every 3 years and modules every year. Using this approach only assures that you will change the media out at the wrong time. The all media use is based on the chemical load with each location, even in the same facility, receiving a different chemical load composition than any other location in the facility. And specifically, even a specific location will receive a variable chemical load over time. If the media gets used up sooner than planned by the calendar, then the space is unprotected, and at the cost of the equipment and the operations is astronomically higher than the cost of a media changeout. If the media is not used up when the calendar says it's supposed to be changed out, then we're spending money unnecessarily before it needs to be spent. With deep bed system changeouts, PureAir provides our manual bed rod to indicate visually how much media life is left and how much has been used up. We also provide media testing in our PureAir lab here in Atlanta as a free service to our media customers. So that completes the presentation. Appreciate your time and your attention. And if there are any questions, you can ask them at this time. Let's see if we have any coming in. Looks like one question we have is the lead time for now for order shipments. And generally, it can vary depending on which media you're purchasing, but it's we're usually saying 6 to 8 weeks from order. And being asked to quantify how much better PP blend is than a carbon media. It depends on a number of factors, but generally when we've been testing it, it's at least twice as good as any competitive brands of media. And I don't see any other questions coming in. So at this point, we appreciate your time and joining us. And we'll make this available to you on our YouTube channel and make these slides available to the viewers. Thank you.